All right, so today we're going to do a couple of additional training sessions. Partly we're going to look at the print and see how they function with regard to fire alarm systems, and then we're going to look at how to wire particular fire alarm devices for our systems. All right, so once again, we're just doing an overview of the prints for the fire alarm system. And when you get to the prints, if you're looking for a particular building in the area where we have our prints, you look for the building name, and then within that building name, you're going to look for something that says Tyco Simplex Grinnell, and usually that's where you'll have the prints for that building's particular fire alarm system. If it's in the overall prints, you'll look in this section of the prints, usually in the electrical portion, and it'll say something to the effect of fire alarm control system. And that's how you find the prints for a particular building. Now, in order for us to understand what these prints are doing, we have to get acquainted with the several elements of the fire alarm system, the prints of the fire alarm system. First, you have to know what the small little symbols on the prints mean. In order to do that, you look at the symbol or wire legend. Most of I would say some of these, they're not going to be devices that we will be particularly working with. They'll be reserved for a technician from Simplex Grinnell. But there are others that we will be acquainted with and be working with. Like a square with the S in it is a pull station. A square with a D in it is a heat detector. And a square with a SD in it is a smoke detector. So these are the primary devices that you'll be working with. And if you're looking at something in particular, you'll want to make sure to understand it properly by looking at the legend in this top right-hand corner. Other things that you might want to know is here you have your wire gauges laid out for you, and what circuits use what type of gauge. For instance, your speaker circuit uses an 18 gauge, and your visual circuit uses a number 14 gauge. So those are kind of the technical understandings for the technical peculiarities for the fire alarm system. Another item that you might want to look at is your master signal circuit schedule. It basically tells you all the information you need to know about your signal circuits. And your signal circuits are your speakers and your visuals. So where there's the visual, the strobe flashing, or where there's something being heard, all that is here. And it basically tells you the circuit number, the level, the location, and up here it tells you basically what you need to know, and then the description of the device. So those are basic layout of things that you'll want to know and you'll want to pay attention to as you're working with the fire alarm prints. All right, so that is the overview of the print. And if we look at a particular device, for instance here, D1 S25, it's telling us the circuit number, and then there's a hyphen, and then there's a number. That number is the device number on that circuit. So this is speaker circuit 25, device number 4, speaker circuit, visual circuit rather, number 11, device number 4. And EOL means end of the line. So every time you see end of the line, that means you'll have to put a resistor at that particular device. And if you're working maintenance with it, you'll see it already there. So that is an overview of the prints for the fire alarm system. And they're pretty, like where it says they are at is where they are, where it says they are in the prints is usually where they're at. Now, if you look at this particular setup right here, um, there are drawings here. Um, and so these drawings are most likely indicating that these devices were moved in a straight line rather than being done in more of this triangular shape. They just ran the devices in a straight line. So just be mindful of that. That whoever installs the there's the plan built are the whatever's printed, and then there's as built. In other words, as it was actually done. So you'll see those different markings in your in the prints. So just be mindful of those. What we'll focus on in this section is just on the devices that we have control and ability to maintenance. And those devices are speaker visuals, and the icon for speaker visuals and visuals is the same. The only difference is that the speaker visual has a SV inside the icon and the visual has the V inside the icon. And then there's another icon here. It's a square with a SD, which stands for smoke detector. And there are square boxes with just S, which stands for station, which means pull station. Those are the ones that you activate if in case there's a fire. So these are your prints, and I'm going to just walk through basically how prints are set up. These prints they'll tell you, it tells you where you're at, and then it also tells you where north is at. So you get a little bit of orientation. It gives you the scale so that you more or less know the distance that you're looking at. So here, this is a suiting building. We're in the lower level, and this is the fire alarm system layout in the lower level of suiting basement. So one of the things that you will notice once you come is that all these devices, especially in a system that has addressable devices, they have numbers to them. And the reason why they have numbers is because in the sequence of the fire alarm circuit, you have to know you have two numbers here. The S21-11, it means this is speaker circuit 21, device number 11, and the V stands for visual circuit 16, device number 1. So basically, you can be in one device and it has two circuits. You have a speaker circuit and a visual circuit, and that's important because these are all sequenced in a manner that you have to make sure that you're not going out of sequence. And the helpful thing about that is if you're ever troubleshooting, you know in what sequence these circuits are laid out. So if you have this device here, the speaker wires to this device are circuit 21, but the visual wires to this device are circuit 16. And this is the difference when you're looking at a device. This is the difference. This is speaker wire right here, and this is visual wire. This is usually 16 gauge visual wire, 16 gauge wire that's used, and it's usually in this same color code, black and red. And then this is your speaker wire. And in your device, here it'll say strobe, and here it'll say COM. And strobe means that you're connecting to this to the visual aspect of it, and COM you're connecting to the speaker aspect of the device. So that means this visual wire will go to the strobe, and then this speaker wire will go to the COM. And then a way to know what wire goes where is the red is always plus, and the black is always minus. And then the same thing here. This common, this is considered a common for like a. You don't put nothing here. And then another aspect of these speaker visuals here, next to device name and number, if there's a visual component to the device, they have what they call the candelas, which is basically the brightness of the visual. And how you adjust that is, I think you can see inside there. Inside here, you can see that there's an adjustment, and basically by moving that tab inside there, you move it to the established or predetermined candela. You have the option to do 75, 15, 30, and 110. Most of these will be 75 candelas, and you do that by internally here. There's a tab that you move with a small screwdriver back and forth. So it's right in here is where you can see. Okay, so that's a little bit of your devices. So you obviously there's a lot of a floor layout or a particular level will have a lot of devices on it, but as long as you know those are your primary devices, your smoke detectors, square box with the SD, the hexagon with speaker visual, with the SV is speaker visual, hexagon with the V is a visual. Then you have triangles with the H, which are heat sensors, and basically those are just different initiating devices, and they're all sequenced. Now, obviously the speaker visuals will be sequenced together, but there are places where your pull stations are sequenced in with your speaker visuals. So the important thing about your prints is paying attention to the details, making sure that you're working, knowing what circuit you're working with the speakers and what circuit you're working with the visuals, because you would assume that only speaker visuals, only these devices take speaker wires. In actuality, these aren't the only ones that take them. Pull stations take the same wires that activate this are also used to activate the pull station. So sometimes this wire will be found in pull stations. So you have to be aware of that. And if you're doing any maintenance on the system and you have to undo a device, you have to know what goes with what. And how you know that is by looking at the device, the circuits that control a particular device. All right, so let's do a little bit of a troubleshooting as well, since we're looking at the prints here. Say for instance you're at your fire alarm panel and you see a trouble, and usually one of the biggest troubles and one of the biggest headache troubles is a ground system fault, because it's very hard to trace. The good thing is that those troubles are usually coupled with it's usually coupled with a trouble from another device, a device that's located near a particular. It's that trouble usually is coupled with another trouble where it has to do with a device. And that'll help you because it'll identify the device, and when you see the trouble coupled together, that device that is also coming in and out of trouble will indicate to you where, at least on the level where the trouble is at. So if that isn't the case, if there's not like troubles in tandem, then it makes it a lot more difficult. And how you troubleshoot is basically disconnecting entire circuits from the fire alarm panel. And the best and easy way to do it, and the one that you'll probably be engaged in the most, is these more simpler ones. If it's a ground fault circuit that it's hard to trace, it'll demand more than likely a simplex technician to come in and find it. But you can always give it a try, and one of the ways that you can try it is by identifying. You basically would have to go to each level, take every circuit of each level, and you have that right here. You have every circuit of every floor, and basically here, and I want to point something out real quick that it's helpful for you to know. These N's stand for NAC panels. So basically, every floor that is beyond, so a little bit of an explanation. Every fire alarm panel has they have like, what are they called? Amps, amplification modules. And those modules give enough power to light up and to cause particular speakers to work. So when you exceed the power that those amp modules are able to distribute, you have to get into what are known as NAC panels, and they're just extensions. They're broader extensions of the notification circuit. So notification circuits are speakers and visuals. So in this particular building, floors number 3 and 4 have NAC panels attached to that. And so don't be thrown off by that N1 there. So here we're in floor number 1. So if we want to come here and figure out what we're working with, we would come here, and everywhere it says floor number 1, we just look, and it tells us everything that we need to know. For instance, here it tells us circuit 22 on floor 1 does speakers, how many speakers there are on that circuit. So on circuit number 22, on the first level, there are 14 speakers. So that means if we want to troubleshoot at least that portion of the system and that portion of the circuit, we would come to circuit 22, we would look for speaker number 7 and disconnect the speaker wire from it. In order to do this, though, you have to use what is known as a wire resistor, and you have to put the wire on the resistor on the wires that are coming, that are in the. So, for instance, you have this device. Let me. And you have, this is device number 7. So you have wires from device number 6 coming into device number 7, and then you have wires going from device number 7 to device number 8. So you have to make sure that when you put the resistor, it's from the wires that are coming from device number 6, because that is the sequence by which the fire alarm panel is detecting the particular devices. So that's the helpful way. So what you do is you divide the circuit, and if you divide the circuit and the trouble goes away, you know that from device 8 to device 14, that is where your trouble's at. If it doesn't go away, then that means your trouble is most likely in the first 7 devices, in the wiring between the first 7 devices. So that way you will have a better form of trying to troubleshoot, instead of going individually to every circuit that you have. Now, there's a way to know um, where your, and this will just be a little bit more technical, but the question is, like, of the 4 floors, what floor is it? If it doesn't say, if, like I said, I was talking earlier, if there's not a tandem trouble, you really don't know. And the only way to figure that out is in your fire alarm panel, all the floors come into that panel, and basically you would have to disconnect every floor. And when you disconnect a floor and the ground trouble clears, that you know that floor is the floor that has the trouble. Now, if you want to get involved in that, that would be up to you. If not, you would just have to call a simplex fire alarm technician, and this is what they do all the time. But if there is a tandem trouble, that means you at least are aware where the floor is at, and that'll give you a little bit of a more understanding of how to go about solving, doing troubleshooting. So those are your common troubles that you'll run into. Sometimes these devices, because they get old, they can corrode and cause ground troubles, or some type of circuit trouble. So basically, how the best way to troubleshoot is get to a floor, get to understand how many devices are on that floor, what circuits you're working with. You know, if you're working with this circuit, which is let me see here. Let's say you're working with this circuit here. This is circuit number 22, device number 2. And if this is giving you problems, or if something in the vicinity of the circuit is giving you problems, you would go to the circuit, determine how many devices there are, go to the middle, disconnect, put your resistor, and then start trying to see if the system clears the trouble, or if the trouble persists. You know that now you can look at the proper devices on that circuit. There's another device that I haven't talked about yet, and it is the smoke detector. So smoke detectors, so in our systems, we have both addressable, non-addressable systems. So this is a smoke detector from a non-addressable system, but what the difference is basically this base. For this is a non-addressable. An addressable system will have more or less the same base, but it'll have dip switches in it, and those dip switches are how the system knows what device this is. So the sequence of the dip switches will determine the address of this particular device. So, maybe we can do a video on addressing, like if you're doing troubleshooting, you will come to a device that has already the address on it. So basically, if you're replacing it, all you have to do is put the dip switches, which are small little switches, eight small little switches, and all you have to do is put those dip switches in the right sequence, and it'll be addressed as the original, the one that you're replacing. So that's important when you're dealing with smoke detectors, because these smoke detectors, so this is true for the smoke detectors, is that the device number, how you tell the how you tell the system what device number it is through those dip switches. For speaker visuals, it doesn't really matter for the most part. In Chapman, it does because for some reason, even the speaker visuals are addressed. But in most of our buildings, our speaker visuals aren't addressed. They don't have dip switches. The only thing that have dip switches are our pull stations, our smoke detectors, and our heat sensors. So those are the areas where we'll have dip switches in most of our buildings. Chapman Center is a unique building. So basically, you would come to the print, and if it says device number 25, then your dip switches have to be aligned with number 25. And basically, every replacement, how do you call it? Smoke detector and a pull station will have inside them a sheet that tells you how you have to sequence the dip switches in order for them to signal the right device number. So if it says number 25, your dip switches have to be aligned in a particular way so it can indicate 25, and you'll know that by using that paper that those devices come with when they're new. All right, so those are the ways that you do troubleshooting. You basically have to get to a floor, and usually you'll have to determine where the middle of the circuit is at, and then you kind of work your way backwards after you find it, or forward depending on where the trouble's at. So another thing about your devices on a fire alarm, what you'll have to want to pay attention to when you're looking at your print is that, say for instance, this right here, this speaker visual is right here, this is the better one. So your speaker visual circuit number 20, speaker circuit number 22, device number 8, visual circuit number 4, device number 9. So basically, if you look at how this is ran, your visual circuit number 7 is here. So basically, the wire comes, it goes in here, and then it comes right back out, and it goes to 8, and then it goes to 9, and then it comes like that to 10. So you have to be aware that you wire these devices in sequence. So the visual wires that come from this device, visual circuit number 4, device 6, go from that to 7, and from 7 it goes all the way to 8, unbroken. In other words, there's no splices. It's connected from device to device, and then that same goes to number 9, and then unbroken it comes to number 10, which it lands right there. So that's how these wires. It's not like you can connect this to here, and then to connect this one to over here, and then connect this one to over here, and then connect this one over here. The reason why it's like that is because it has to follow a sequence. Remember in our previous video, a while back, we said that how the fire alarm system detects an abnormality in its devices is because every so many seconds it sends a circuit signal throughout the entirety of the system, and it waits a response back. And if it doesn't hear a response back, an electrical response back, it determines that the system is in a sort of trouble. So you have to know that that's how these are wired, and that's the same way for the speaker circuit. So right now what we're going to do is we're going to demonstrate how it is that you are to um, connect a speaker circuit and a visual circuit. So, like the legend said, these are 14 gauge, and then this is 18 gauge. So basically, on this device, you have your strobe side and your comm side. So your strobe is your speaker, your visual, and your comm is your speaker. So your visual wire will be connected here, your number 14s, and your speaker wires will be connected here, your number 18s. So this is 18. This wire here is 18. And then this is your number 14. Now, it depends on the specifications. Sometimes these wires have internal, in order to resist. All right, so when you're going to wire up a device, basically, you're going to have usually two wires coming out, and this is you'll do this if you have to make any adjustments. Maybe the ground fault is because your device is not connected properly. So this is what we're going to do here. I want to show you how we connect these devices. So say for instance these are your two wires. What you're going to do is you're going to cut these. Basically, you're just going to cut the outer jacket. Then you're going to peel back, and you see how it has this protective cover. This is your this sheathing is to prevent interference. Is to prevent from other frequencies interrupting the circuitry or the communication between the system inside the system. So you can cut that off, you can rip it off, and then this is your ground. This is your little ground wire. So you have your two communications wire and your ground wire. So the reason I cut this is just to expose this rip wire. I mean this rip basically string. And what I'm going to do here is use this rip string to cut into my jacket. The reason why I'm doing this is because when I cut this here and made my first cut, I don't know if I nicked the wire and now that wire is exposed and that's going to cause a ground trouble later on in the future. So I don't want to mess with that. So what I'm going to do is, and sometimes you have to just cut a little bit off, kind of in a V shape, just so that this rip wire can like go into it and then it'll rip easily. You see that? So this is what I'm doing. So I'm going to do about 3 inches like that, and then I'm going to cut that original where I originally cut. I'm going to cut that off because I don't know if that wire was nicked or not. I know that this here is not nicked because I cut the jacket with my rip cord. And so now I do the same thing and I take that piece off. You don't need the interference jacket, at least not now. And so, and then you can also cut this the rip cord off as well. You don't need that. You just need it to rip, and then after that you don't need it anymore. And then you do the same thing for the other for your other wire that you're working with. You come here, you cut the outer jacket, and again you use your rip cord to rip it down, and then all right. Okay, you can rip it a little more. So you do a couple inches of your, this is just unique because so you know that that is this here is for sure won't be nicked because you didn't use your pliers to cut this. It was exposed by using your rip cord. So once again, I take off this interference shield and this rip cord, and I cut all that off. So this is what I'm left with, is both of my wires. I gotta cut this sheet. Okay. This is what I'm going to connect with. So basically, what I'm going to do now is I'm going to twist these together. These are my grounds. These are important to connect together. You don't have to do the whole thing, just about an inch. And then you cut it off, and then you twist it back. So that is your connection. And then you take your tape and basically you make sure that nothing metal-wise is exposed, because that will create your short circuits. So you come here and you tape it like that. And then if you want to put all these, level or even, you can do that. Okay, so in order to wire, you're going to wire your speaker wires to your device. And you'll want to form your wires so that when they're about to go in, you're not fighting with them a lot. So this is how you'll want to, you see, if once I slide it in, let me open this up real quick. So you'll want to slide in your wires like that. Remember, your positive is red, and your common is your black. So you'll come here, and I'm forming it so that it fits in just like that. So I still got to take off these for the black ones. And again, what you're stripping away is about 1/4 of an inch. It's not that much. It just has to be enough exposed enough so it can make contact with your terminals. So you come in here and you slide it in like that, and then you tighten it down. You're good to go. These just have to be snug, nothing super tight. And then this is how you make a connection for your speakers. So it's 14 gauge, but basically it'll look just like this, a little thicker, 14 gauge, and then both of your blacks will go here and both of your reds will go here. And it's a little simpler because you don't have to do all this. You don't have to tape nothing. It's just basically you peel about 1/4 inch to 3/8 of an inch off the ends, and you stick it in here. Again, you follow the same sequence. Plus is red, minus is black, and you would just stick them in here, and that would be how you. The more intense or more time-consuming splice, or not I'm sorry, splice is the wrong term. You don't want to splice ever in a fire alarm system. The most consuming termination is your speaker termination, because they have to be interlocked in this fashion. So those for your um, for your smoke detectors, those use so your pull stations. This is a non-addressable smoke detector, so this one doesn't have it. But your addressable pull stations and addressable smoke detectors, those are connected by the speaker wire. So the speaker wire is for speakers and addressable devices. Those are the wires that are used for, those devices use speaker wire. Your pull stations, and anything that can be addressed, your smoke detectors, your heat sensors, your speaker, your pull stations, your smoke detectors, heat sensors, and your pull stations are all addressable, and they all use this type of wire. And in addition to those devices, your speaker or your visuals also use that. Your speaker portion of your speaker visual device also uses that. There are devices that are just the speaker, and there are devices that are just the visual. And in those instances, obviously, if it's just a speaker, you use your speaker wire, and if it's just a visual, you use your visual wire. All right, I think that is wraps up what we want to do today, and hopefully that will help you and assist you in trying to make sure you are being effective in taking care of the fire alarm system. Thank you so much, and I hope you find this video helpful.